Hey, today I want to talk about a secret weapon in machine learning, regularization. You've probably heard about overfitting, the moment when a model becomes just a little too obsessed with its training data. It memorizes every tiny detail, even the random quirks, and then falls flat on its face when given something new. Not ideal, right? That's where regularization steps in. Think of it as a coach that says, hey, don't get too attached to any one feature. Let's keep things balanced. So here's how it works. Every machine learning model has a loss function, a way to measure how wrong it is. The model's job during training is to make that loss as small as possible. Regularization tweaks this function by adding a penalty. Sounds harsh, but it's actually really helpful. This penalty is all about the weights, the numbers that decide how much importance each feature gets. If a weight gets too big, the penalty kicks in and says, whoa, slow down. And that's controlled by a knob called lambda or lambda. It's basically a dial that says how strict the penalty should be. Crank it up high, and the model becomes super cautious, maybe too cautious. Turn it down low, and the model might go wild, fitting every bump in the data. Now, there are a couple of flavors of regularization worth knowing about. First, L1 regularization. This one adds up the absolute values of the weights. If a weight isn't pulling its weight, see what I did there? L1 can push it all the way to 0. That's like telling the model, you don't need this feature, just ignore it. So L1 is great for feature selection. Then there's L2 regularization. Instead of absolute values, it squares the weights, which means bigger weights get punished even more. But L2 rarely pushes them all the way to 0. It just makes them smaller, nudging the model toward simplicity. It's less dramatic than L1, but super effective at taming those less important features. And if you want the best of both worlds, you go for ElasticNet. This one combines L1 and L2, so it can pick some features to drop completely, while giving others just a gentle nudge. It shines when you have lots of features that are similar or correlated. So why does all this matter? Because regularization keeps your model honest. It forces the model to stay simple and not get carried away with the noise. That way, it doesn't just perform well on what it's seen. It's ready for the real world, with all its surprises. In short, regularization helps strike the perfect balance. Not too simple, not too complex, just right. So the next time you're building a machine learning model, remember to give regularization a try. Your future self and your data will thank you. Thanks for watching.